planting should be limited. It was once thought that up to 1/3 of the crown of a newly planted tree should be thinned to compensate for the loss of roots. This practice was known as compensatory pruning. Research shows that trees will grow and establish more rapidly if pruning is limited to removing broken or damaged limbs. Although the need for pruning at the time of planting is usually minimal, trees should be pruned while still young to establish good structure. Training young trees can greatly reduce the need for drastic structural pruning later on. Many defects, such as weak branch attachment and codominant stems, can be corrected early, creating trees that are structurally stronger than untrained trees. Structurally stronger trees have a lower potential for failure. The leader is the central stem of the tree. Generally, there should be only one leader. If competing leaders exist, the strongest, most vertical stem should be maintained while the others are removed or cut back. If the central leader has been broken off or has died back, a vigorous, upright branch should be selected as the new leader. Follow-up pruning will be needed in subsequent years to remove or cut back newly developed competing stems and to ensure that the new leader is in a vertical position. Click on the play button to watch the video.
The leader is the central stem of the tree. Carefully follow the trunk of the tree from bottom to top. The trunk should narrow into a single stem that is in a vertical or nearly vertical position. This is the leader. There should be only one leader. If there is more than one leader, then the strongest and most vertical stem should be selected as the central leader, and competing leaders removed or cut back. The leader should be vigorous, well attached, and in a vertical position. If a central leader cannot be found, then select an upright, vigorous branch that is closest to a vertical position. Again, competing branches should be cut back or removed. Trees that have sustained a broken leader need to be restructured. Cut the damaged leader back to a codominant stem, a vertical branch, or an upright bud. Remove competing stems. Follow-up pruning will be needed in subsequent years to remove or cut back newly developed competing stems and to ensure that the new leader is in a vertical position.
The spacing, balance, and attachment of the limbs should be evaluated. While some limbs may be removed for structural stability or appearance, the central leader should not be removed. Proper training of young trees to produce a strong branch structure is important. Generally, however, it is preferable to start these procedures after the tree has become fully established. Trained trees often require less maintenance when they are mature. Well-spaced branches provide easier access for arborists, and pruning can be accomplished in a shorter period of time. Finally, trained trees might not have costly structural defects that require correcting through cabling, bracing, canopy thinning, and codominant stem removal. It is recommended that no more than 25% of the canopy of a tree be removed in any 1 year. In some cases, removing only 5 to 10% is sufficient to develop good structure and form. With particularly fast-growing trees or trees with significant defects, it might be necessary to remove more than 25% of the canopy. A young, healthy tree can usually tolerate this heavier pruning. Training may begin as soon as the newly planted tree has become established. The frequency and duration of training depend largely on the individual tree's needs. A general guideline is to prune at ages 2, 5, and 10. Training should be replaced by maintenance pruning once the permanent scaffold branches have been established. There are many resources available for arborists that contain detailed pruning specifications, such as the ANSI A300 pruning standard and ISA's Best Management Practices Tree Pruning Companion Guide. The 5 steps of young tree training. The procedures for training young trees can be summarized in 5 simple steps. 1. Inspect the canopy and remove or subordinate broken, dead, dying, diseased, or damaged branches. These branches do not provide a significant biological or structural contribution to the crown. Removing diseased or dying limbs also allows for better wound closure. 2. Select and establish a central leader. In a forest environment, young trees usually maintain an excurrent form with a single leader as they grow toward the canopy. In contrast, many of these trees develop competing or codominant leaders when grown in open sites where major structural defects can form as these trees mature. Select the strongest and most vertical stem as the leader and remove or cut back competing stems. 3. Select and establish the lowest permanent branch. Look for a well-attached branch at the desired height and remove closely spaced competing branches. The target height is determined by the tree's location and use. The diameter of the lowest permanent branch should be no more than 1/2 that of the central leader or trunk at the point of attachment. Smaller temporary branches should be left close to the lowest permanent branch. Larger temporary branches should be pruned back to 1 or 2 buds. 4. Select and establish scaffold branches. Look for well-attached branches above the lowest permanent branch that have no more than 1/2 the diameter of the central leader. Scaffold branches should be well spaced both vertically and radially. Vertical spacing should be approximately 18 inches, 45.7 centimeters, or more for the larger trees, and 12 inches, 30.5 centimeters, for smaller trees. Radial spacing should allow for balanced branch distribution around the central leader. Leave small branches close to scaffolds as temporary branches and cut back or remove larger branches. Click on the play button to watch the video.
The lowest permanent branch is the lowest branch attached to the trunk that will remain on the tree throughout its lifetime. The location and use of the tree usually determine the position or height of the lowest permanent branch. For street trees, the lowest permanent branch over the sidewalk may be 8 feet, while over the street, the lowest permanent branch may be at least 14 feet. For trees in a planting strip, the lowest permanent branch may be 6 or 7 feet, if it is positioned parallel to the planting strip. The first permanent branch for trees in parks or yards will often be lower than that for street trees, but this will depend on specific use and perhaps on maintenance considerations. Look for a vigorous branch with a strong attachment that meets the height requirement. Always avoid selecting branches with included bark. Branch diameter should be 1/2 or less of the trunk diameter, where the branch attaches to the trunk. You may want to label this branch so you know that it has been selected as the lowest permanent branch and you can identify it later. Diameter growth of some branches may become equal to or greater than that of the trunk at the point of attachment. This constitutes a structural weakness. Ideally, scaffold branches should be 1/2 the diameter of the trunk or less.
5. Select temporary branches below the lowest permanent branch. Some or all of the branches below the lowest permanent branch can be retained as temporaries. If possible, leave the smallest branches and cut back or remove the largest branches. Temporary branches help build trunk taper and contribute to food production, but because they will be removed later, they should not be allowed to grow to significant diameter or compete with scaffold branches. Planting specifications are detailed plans and statements of particular procedures and standards for planting trees or shrubs in a landscape. Arborists often work with contractors from other green industry professions and must write planting specifications before they bid out work. Other times, arborists must work according to these specifications to fulfill a bid. The amount of detail and breadth of these specifications can vary greatly. The following section will provide an overview of what can and should be included when drafting a planting specification. When writing a contract, it is important that all of the key terms be clearly defined. What constitutes a healthy or vigorous plant may be different for each party involved in a bid. Timelines should be established for each step in the installation process and should include deadlines for any follow-up maintenance or inspections. The length and terms of any warranties should also be defined and documented within the planting specifications. Guidelines such as the American Standard for Nursery Stock, ANSI Z60.1, provide a system for sizing and describing trees and shrubs. Planting specifications should be drafted using the terminology found in the Tree Planting BMP and the ANSI A300 Transplanting Standard. The ANSI Z60.1 standard does not provide assurance of the health or quality of nursery stock. Rather, it serves as a tool for communication and to facilitate trade. A typical planting specification contains 4 sections. 1. General description. The first section is a general overview of the project and provides the following information. A. Description of the work to be done. B. List of key terms and their definitions. C. Standards and nomenclature used, such as the ANSI A300 for transplanting standard and the ANSI Z60.1. D. Requirements that the contractor must meet before bidding, project timeline, or the submission of material samples. 2. Shipping and handling of plants. Acceptable handling techniques should be identified as well as preferred methods of shipping. Practices that prevent damage to trees and shrubs should also be described. This section may include the following provisions. A. Irrigation at the planting site for trees not planted on the same day that they arrive. B. Measures to prevent wind damage and desiccation during transport. C. Proper techniques for handling nursery stock. 3. Plant and material requirements. The planting specifications should contain a detailed list of plant and material requirements, including A. Plant species and cultivar. B. Minimum, maximum size requirements. C. Condition of roots, trunk, and crown. D. Special requests such as marking the north face of the tree trunk or wrapping the root ball in plastic to prevent desiccation during storage. This section should also include information about materials to be used in the installation, such as A. Mulches. B. Stabilization systems. C. Pesticides or fertilizers, including formulation or brand. D. Acceptable substitutions. 4. Execution. The final section should clearly define acceptable installation techniques and maintenance requirements of the landscape. The execution section should include A. A schedule with start and finish dates. B. A thorough description of acceptable installation practices, planting depth, mulch dimension, stabilization methods. C. Maintenance requirements after the landscape has been completed. D. Frequency and terms of maintenance if required. Mulches are materials placed over the soil surface to maintain moisture, reduce competition from weeds and turf grass, and to improve soil conditions. Mulching is one of the most beneficial things that can be done for the health of a tree. Mulch can reduce water loss from the soil, minimize weed competition, and improve soil structure. However, if mulch is too deep or if the wrong material is used, it can actually cause significant harm to trees, so proper application is important. Mulches can be classified into 2 basic categories, organic and inorganic. Staking or guying of newly planted trees is not always necessary. In fact, staking may even